Good evening. Tonight we're going to look at how different forms of potential energy are converted into kinetic energy. In our first example here, you'll look and see that we have the stored chemical bond energy in coal. When we heat coal up enough, it breaks the bonds, and those bonds release heat energy. We can use that heat energy to heat up water. The molecules in the water start moving really rapidly fast, eventually turning into a gas we call steam, which is water vapor. The steam creates pressure in the boiler. That high pressure steam is then shot down a pipe to turn a steam turbine. The mechanical energy is then used to move an electrical generator. That electrical generator is then converted into electrical energy, and we get the radiation of light. So you start with the potential energy in the chemical bonds of coal. When that energy is released, a lot of it is lost to the environment in the form of heat and light and sound. Enough of that energy is absorbed by the water, which causes the molecules of water to start moving around very rapidly. So the potential energy in the chemical bonds of the coal is converted into heat and light and sound. And the heat is absorbed by the molecules of water, and those molecules increase their kinetic energy of motion. So much so that they actually change their state and form steam. The boiler traps all the high pressure steam and shoots it down a pipe and causes it to turn a steam turbine. And the mechanical energy of the turning of the turbine turns the electrical generator, and the electrical generator converts that energy into electricity and transfers it to a light bulb, where it is released as electromagnetic radiation of light. A very important concept here is to realize that all of the potential energy contained in the chemical bonds of this coal does not disappear. It may not all get to that light bulb, but it is all converted into different forms. We said in the form of heat, sound, and light. So the stored potential energy in the chemical bonds of the coal are converted into the several different types of kinetic energy. Some of that is harnessed and converted into light, and some of it is lost to the surrounding environment. Let's take a look at another example. Let's look here at how the energy is lost to the environment. If we start off with the energy content of coal equaling 100 units, as the power plant converts that energy into usable forms, it loses 62 units. So a very large percentage of it is lost in the form of thermal energy, of heat, sound, and light, radiation. But we were able to capture enough of that power to create enough kinetic energy in the water molecules to convert that energy to steam, which creates enough pressure to power the turbine and electrical generator to convert that potential energy in the coal into kinetic energy of electricity. And then that electricity is transferred down the transmission line. So when that enters the transmission line, you still have about 40% of the energy left, 38% to be exact. As it travels down that line, it loses energy to the environment. And if you've ever been near high power lines or high tension wires before, you've probably heard a buzzing or a sound. So you can actually hear it losing the energy in the form of sound. And if you've ever been around that, you can feel the electricity in the air sometimes. You might even get a shock by touching somebody next to you if you're near high tension wires. Okay? So by the time it enters a home, a light bulb may be using 36 units of energy. Once that light bulb lights up, it loses a lot of that energy in the form of heat or thermal energy and radiation, light energy. Now, the law of conservation of energy states that energy is never lost, it is just converted into different forms. And you can see that here. We start with 100 units of energy content in the coal, and as we go through the transformation from the stored chemical bond energy, potential energy in the coal, to the radiation of light energy that we use to light our light bulbs in the house, we see that along the way, that energy is converted into all different forms, including thermal energy, sound energy, radiation, and heat, thermal energy, again. So none of this energy is lost. It is just converted into different forms. So you may even look at it and say, wait a second, to light this light bulb is not very efficient. We enter with 100 units of potential energy, but we only really get the usefulness of 2 units of energy in the form of light out of it. So we have the invention of new technologies that are able to harness the light or the energy from that coal in a more efficient manner, so we don't lose as much of the energy in the form of heat and we gain it in the form of light. Okay? Let's look at a different example. Here we have a hydropower plant where we have the potential energy of the water behind the dam based on its position. Okay? Dam builders created this system, so the lower the opening to the dam, the more potential energy the water has, because there's more force being pushed down and into what we call the penstock, all right, past the control gate. So when a hydropower plant wants to create power, they open the control gate and they allow a certain amount of water to flow through the penstock and spin this turbine. As that turbine spins, the potential energy of the water is converted into the mechanical energy of the spinning of the turbine. All right, which then powers the generator. All right, the generator transforms that mechanical energy into electrical energy inside the powerhouse, and it is transmitted down the power lines to your home to light your house up or power your refrigerator or your microwave, or more importantly, your TV. Energy is lost in the form of thermal energy and heat all along the way, but it does not disappear. So while the energy that arrives at your house may be less than the amount of energy that is produced here at the power plant, the energy does not disappear. And we base that, if you remember, we talked about that. That is called the law of conservation of energy, which states that energy is never lost. It is simply converted into different forms or types of energy. And that's all we're going to discuss tonight with regard to energy conversion and the law of conservation of energy. Hopefully you're starting to understand and get the big picture. That energy that exists can be converted into different forms. It can be converted from potential energy to kinetic energy, and that kinetic energy can also be converted back to potential energy and stored for later use. But the energy that exists does not disappear. It simply changes form. And that's the concept, or the law of conservation of energy.